Once again, we're asked to differentiate a log function. And remember, the first rule as we're getting into this is if we have a log base like this, we want to rewrite it as natural logs. So if we're going to take a derivative here, I'm going to say this is the same as saying natural log of e to the negative x cosine of pi x divided by the natural log of 2. You can't forget that rule. When you have a log base like this, you can change it to the natural log of the input on top over the natural log of the base. That allows us to actually play around. And we can mess around with it even more, can't we? Because we know that this is also going to be equal to, when two things are multiplied like these here, these functions can be separated. And I'm going to say this is more like ln of e to the negative x plus ln of cosine of pi x. And that's probably exactly what they want us to do. That's why they offer us this question. This is all going to be over the natural log of 2 yet. Well, why do this? Because e to the negative x here is very close to what we want, because ln of e to the anything just gives us that in return. So that should just be negative x right there. And then we'll do a plus ln of cosine pi x here. We haven't really addressed that yet. That's all over ln of 2. Still, I feel like this is a great starting point. None of this is calculus yet. This is all algebra that we probably skipped in 7th through 12th grade because natural logs were scary and our teachers had an education degree instead of a math degree. Now that we have something useful, much simpler, we can actually differentiate it. So we'll take the d dx, because x is what we're taking the derivative with respect to here. And if we want to compute that, well, excuse me, I'm just coughing just a little bit there. I think maybe we'll do them one at a time. So I'll rewrite this real fast, and then we'll take the derivative as negative x over ln of 2 plus ln of cosine pi x over ln of 2. And do them separately this way. It makes it a little more obvious that this is going to become negative 1 over ln of 2. And this one here, well, this is going to be a chain rule function, right? Because here's an outside function, and then here's an outside function, and then an inside function. So we'll start with the first part, which would be 1 over the input, which is cosine of pi x. Then this whole thing will be divided by ln of 2. So I'll just put it down here for now. Times chain rule, what's the derivative of cosine? That's negative sine pi x. And then chain rule again, what's the derivative of pi x? That's pi. So I think what we're looking at so far is negative 1 over ln of 2 plus, I didn't write it there for some reason, negative sine over cosine would be, we'll make that even a minus like this. This was still a plus up here. Minus, I want to say that this is a tangent of pi x. That makes u and u go away. So we have a times pi over here, and all of this is going to be over ln of 2. So if I take a minus 1 out, this would become a plus here. You know, the minus is out here somewhere. So we're going to get, I want to say minus 1 pi tangent pi x over the natural log of 2. And if you really want to get cute with it, I think we would want to take this out too. So maybe we'll write it this way. Negative 1 over ln of 2 times, there's an ugly looking parenthesis, pi tangent pi x. Where'd the plus 1 go? I missed that one. Remember back here, this term here? So I need that. 1 plus pi tangent pi x. And that should be the answer.